Hi, welcome to the video on simulation of solid state drives. In this video, we are going to see how to simulate switch reluctance motor drive using MATLAB SIMULINK. Before we go into the simulation, we need to know the magnetization characteristics of a switch reluctance motor. So the magnetization characteristics of a switch reluctance motor is given in the form of a table here, and it has been taken for various rotor angles starting from 0, 10, 20, 30, 40 and 45, and for various stator current in amperes starting from 0 till 450 in the step of 25. And this magnetization characteristics is very important to simulate the switch reluctance motor drive. So now I'm going to take this table in a M file and I'm going to make it in a form of a variable. So let me do it first. I'm creating a new script, and in this script I'm going to make this table this as y-axis and this as x-axis. So I'm going to put it in a form of a table. So for which I already made it, and I'll just open it and show it to you to understand how this has been taken. And this is the data which I've shown in the table. This table data has been made in a form of a variable here. So once this variable is uh, uh, made here, let me run this file. Once I run this file, I'll get this FTBL variable on my workspace. So I'm taking uh, sampling time also as TS, which is equal to 1 e power minus 6. Ts is equal to 1 e power minus 6. So let me take this sampling time also as another variable. So now I have two variables in my workspace. One is FTBL, which is the magnetization characteristics of the switch reluctance motor. Another one is the sampling time. Now let me go into the simulation. So here I'm going to the library browser. In the library browser, I'm going to the SimScape. In the SimScape, I go to electrical. Under electrical, specialized power systems. Under specialized power systems, I have electrical machines. Under electrical machines, I have a motor called a switch reluctance motor. I drag it and put it on the screen for my usage. Now I double click on this. I put the stator resistance as 0.05 and inertia also as 0.05 and friction as 0.02. 0.02. And sampling time, as it is already mentioned, I put it as TS. TS. So this is my sampling time. I click apply and give OK and OK. Now I need to fix the magnetization characteristics of this machine. Again, I go here. In the model, I go to a specific model. Under specific model, I go to source dialog. In this dialog, I put that variable which we have created now, FTBL, as my one of the variable here. Apply. And this is how the magnetization characteristics has to be linked to the SIMULINK model. We can just click this plot magnetization characteristics and click apply. You could able to see a set of plot for current versus flux linkage for various angles of rotor. And this figure has to be copied and it has to be taken as a printout for your documentation purpose. So, and click apply and give OK. Now I will close this figure. This is not needed, and let me take it. Now this is the switch reluctance motor which you are trying to simulate. Now I need to design a converter for this three-phase switch reluctance motor. It is having three phases: A1, A2, B1, B2, and C1, C2. So for the converter, I need an IGBT. So again, I go to power electronics. Under power electronics, I have IGBT, the normal IGBT. I take it and put it on the screen, rotate it comfortably in my screen, and this collector has to be come to the up. So what I do is I right click mask, right click format, flip block up down. So this flip block, up down. Yeah, the collector has come up. Now I double click on this and I need to put the stator resistance, snubber resistance and the capacitance value. Stator resistance is 1 e power minus 3 and react resist snubber resistance is 200, resist on resistance is 1 e power minus 3, snubber resistance is 200, and this is 0.1 e power minus 6. And I remove this show measurement plot and click apply and give OK. And this is supposed to be the power converter which I am designing for the switch reluctance motor which I am trying to drive it. Now I need a diode. A diode can be taken here, rotate it and put it on the screen, double click, and this is again 1 e power minus 3 like the normal thyristor, I mean normal IGBT I used, and snubber resistance is supposed to be 1000, and capacitance, it is an infinite capacitance. So INF, and remove the show measurement port, click apply and give OK. Now this is I'm trying to design the converter for the switch reluctance motor drive as I indicated already. Now I need a diode here, a IGBT here, and I connect everything like this. I connect this, connect these two, put it little bit, stretch it, connect these two, stretch it, and I need a gate. This gate is common for both the devices, and I need two lines to be taken from the top and bottom and middle of these two legs. This I am supposed to do it now. You need to press control button while doing this, and this is for one particular phase. So I select this and create a subsystem, double click on this, and this is supposed to be the gate signal. So I put as gate, and this is supposed to be V voltage plus, so V plus, and this is supposed to be voltage minus, so V minus, and this is supposed to be the uh, winding input, so I put A1, and this is supposed to be the next winding, so I put A2, other end of the winding, so I put A2, and this is the for one particular phase. I can just right click, format, content preview, I can close it so that I will feel comfortable. So this A1 is let it be on the top and A2 be on the bottom, V plus on the top and V plus on the bottom. This is for one particular phase. I need for 3 phases. So I put double click and I change this to B1. This is B1 and this is supposed to be B2. This is for the second phase. And similarly, I do it for the third phase. And this is for double click. I put it as C1 and this is C2. Okay. Now I completed all these 3 and I take this plus and this minus, and this plus has to be connected here. So for which I need to press control and do it. Yes, I've taken all the plus and minus, and this gate is supposed to be a common gate. For the gate, I need a DMX. DMX is available in Simulink library block. DMX. There are 3 gates, so double click. I put 3 and extend this. This is supposed to be for this first gate, for the next one, and for the third one. So I put all these 3 gates here. Okay. Now I will select everything and create this as a subsystem so that this can be given to all the 3 phases of the machine. So this is how I right click, format, remove the content preview so that this looks easy, and this double click, and this is supposed to be the gate. I rechange it, gate signal, and everything is remaining same, A1 B1, A2 B2, C2 C1 C2. So now I can connect this motor with this particular drive, I mean the converter. I connected everything. Now I had to give an input supply to this. So for which I had to go to SIMULINK, SIMScape. I have electrical sources. I have a, sorry, this not this one. Specialized power systems. Under specialized power systems, I have sources. Under sources, I have a DC source, and I put it on the screen, and I connect to the positive and negative of the converter. And this voltage is supposed to be 240 volts. 240. Yeah. And this is how the drive has been connected to the switch reluctance motor. Now let me take a bus selector from the commonly used. I connect it to the output of the motor and let it be little bit uh, extended one, so that I had to take 3 to 4 signals out of it. I double click on this. I want to have, I remove this. I want to have flex. I add it. Current, I add it. Torque, I add it. Speed, I add it. And I remove this signal. Okay. And hit OK. So now I'm having 4 signals out of this. So let me track it and put it on the center of the screen. Let me take a scope and connect the scope here. Scope. Double click on the scope. I'm going to have 4 axes because I'm going to plot 4 terminals. So 4 and the grid display grid, let it be 2 cross 2. So this is supposed to be 2 and this is also supposed to be 2. 2 cross 2 and OK, put OK, and I stretch this and connect each and every output to this scope, so that I could able to see what is the signal which is coming out of the bus selector. So first one is speed, second one is torque, third one is current, and fourth one is the flex. Now I want to create a control system for this. So for which I try to go to create another block. Let me take a gain. Gain is available here. Yes, I put a gain, and this gain is, I have an value of 180 by pi, 180 by pi, and click apply and give OK. And let me stretch this so that you could able to see the value of this. And let me take a discrete time integrator which is available here. I put it, drag it, and I have it here. Double click on this. Initial condition is supposed to be 0, -30, and -60. And sampling time, as it is already given, it is supposed to be TS. Click apply and give OK. Now I need a math operator which is available here. In that math operator, I have math function. Take it and put it on the screen, and I select mod from this. I have mod. Yes, I give one output here. For another one, I need a constant which I take it from here, and I put 90° as the constant here, 90°. And this is the next step to be followed. I need a relational operator which is again available here. I take it. One is supposed to be greater than and other one is supposed to be less than or equal to. So less than or equal to, I take it out. I put it here. Both the mod functions, I put it, and I need a AND gate logic. AND gate, I connect it something like this. Yes, AND gate logic. The output of the comparator relational operator should be an AND gate. Yes, this is how it is being followed. Yes, now I select everything and I'm creating a subsystem from this selection. Yes, now it looks like this. Yes, I don't want to have a preview, so I format mask and content preview, I remove it. I remove this. Yes, and this signal is supposed to be alpha. I put as alpha. and this is supposed to be beta, and this is supposed to be omega, the speed, and this is the output of the block. So I get three different values here, and this is how it will be looking like. So let me select everything, put it on the center of the screen so that I can be able to make it easier. Okay. Now I need two more constants for alpha and beta. I need two constants for alpha and beta. Alpha is supposed to be 45 and beta is supposed to be 75. Alpha and beta has been given, and I need omega. Omega is available here. So let me put a control and take that omega and give it to this particular point. Yes. The omega has been taken and fed back into the input signal. I need a multiplier, which is again available here. I take a multiplier. I multiply this output. I multiply this output with a constant of some reference value. Let me take it as some value here. So let it be some value of current. So let it be 200. 200. I multiply. This is supposed to be the reference current, REF current, which I want the machine to take it. And let me have this comfortably in the screen, little bit like this. I stretch this output. Yes. Now I need a summer block. Summer block is here. I take it, put it here, and this is supposed to be plus and minus. I want to compare this current with the reference current. Actual current, reference current is this. So actual current is somewhere I here. So I take this and feed it back. Now I have a hysteresis controller is needed. It is a current control method. So for which I have a discontinuities in SIMULINK. Under discontinuities, you have a relay block. Put a relay block and connect it to the gate. This is how it has to look like. We need few settings on this relay. Let me do it. I double click on this. You can just have some value like 20 and switch off point as -20. Or even I can have it as whatever you need it. Apply and give OK. And I need a torque block, which is supposed to be, let me run it initially in no load condition. I put 0. 0 is my reference torque. Okay. Now I need a power GUI block to simulate any power electronic simulation. I put it here. I double click. I convert it into discrete and let it be 1 e power minus 6 as we decided earlier. 1 e power minus 6, click apply and give OK. And stop time, let it be 0.5. 0.5 is the stop time. Yes, everything is completed now. Let me run the simulation. Simulation is running for 0.5 seconds. Now let us go to the scope and see the results. Yeah, now look at this. The speed has been slowly increasing and settled at around 400 radians per second. So if I want to view that in a form of a RPM, let me again go to SIMULINK, commonly used to have a gain block. You multiply it with 30 by pi. So this becomes 30 by pi. 30 by pi. If I put it here, let me put it here. Put it safely here. Yes. Now again I run. Yes. Now the current is around at 200, so I can decrease this band if I need. I can go to this relay and put some 0.5 as my switch on point and minus 0.5 as my switch off point. You could able to see the difference in the ripple, current ripple. Again, it takes a little bit time to simulate. Yeah, look at this. The magnitude has been reduced very drastically. And this is the current waveform, flux waveform, torque waveform, and the speed waveform. Yeah, this is how we generally do the simulation of the switch reluctance motor drive. And very important point is you want to make this plot, uh, magnetization curve for plots, and you have to take this and put it in a form of a table here. Thank you for your patience listening. Do this and complete the simulation and enjoy the simulation and learn through the simulation. Thank you.